This is the Unit 4 Skill 2 video covering the substitution method. And this is a method to help us solve systems of equations. So our whole goal is to find that shared point, the x and the y, when given two equations. So let's look at our first example. One equation is y equals negative 2x minus 4. And the second equation is negative 7x minus y equals negative 6. Now we've already practiced our graphing method for solving, where we would graph both of these lines and we would find where they intersect, right? That would be the shared point that we're referring to. But substitution method is another way to find that x and y value. So we start by making sure that one of the equations has a variable by itself. Like here, our top equation already has y by itself. Okay, so that's important. That's how you start substitution method. And so this piece here, negative 2x minus 4, that is the substitute for the letter y. Okay, this is what y is equal to. So we come to our second equation and we find the letter y, and we're going to substitute negative 2x minus 4 in for that letter. Okay, so let's rewrite. We'd have negative 7x minus, now this is where we plug in the substitute for y, okay? In parentheses, negative 2x minus 4, okay? And then write out the rest of the equation equals negative 6. So notice, instead of this letter y, we've written in the substitute for y from the first equation, okay? Negative 2x minus 4. Now, in red, we have an equation with only one variable, the x, and we can solve it for a single number for x. So let's go ahead and do that. I would start by distributing that minus sign outside the parentheses. So we have negative 7x plus 2x plus 4 equals negative 6. I combine my like terms and get negative 5x plus 4 equals negative 6. Subtract that 4 from both sides. And I get negative 10. And finally we divide, and x equals positive 2. Okay, so we have solved for one of our two variables. I know that the x value is positive 2 for that point that these two equations share. And now I need to find y. Well, for either equation, I could plug in this value of 2 in for x and solve for y. But notice that first equation is already for me to solve for y, right? It's already y equals. So I'm going to bring this back up. It's kind of my second substitution. And I'm going to write y equals negative 2 times x, right? This is where I'm plugging in that x value of 2 that I already solved for, minus 4, and then you solve. We just get our single number answer here. Negative 2 times 2 is negative 4, minus 4 is negative 8. So y equals negative 8. As an ordered pair, x is 2, y is negative 8. And this is my solution. If we had graphed these two equations, this is the ordered pair where the two lines would have intersected. Let's look at this process again with another example. All right, let's practice substitution method with this problem. We've got x minus 6y equals 9 and negative 2x minus y equals 8. So as I look at these two problems, remember our first step is to find one equation that has the x or the y already solved for, already isolated, but we don't have that here. Okay, so we want to find the easiest variable to get by itself. So typically, I'm going to look for the variable that has a positive 1 out front. That would be really easy to solve for. Okay, imagine all we need to do is add that 6y over to the other side, and now we've got x by itself, right? X equals, and it doesn't matter the order on the other side, so I could write 6y plus 9. Notice it doesn't have to be y equals, because we're not trying to graph here, so it's fine if it's x equals. So now I have x by itself, and I have its substitute, right? X is equal to 6y plus 9, and so I'm going to find the letter x in the other equation, right, in equation 2 down there, and that's where I'm going to plug in 6y plus 9. So let's go ahead and do that. Negative 2, because that's the multiplier, times 6y plus 9, and then the rest of the equation, minus y equals 8. And we solve now for y. Y is the only variable still present. I distribute that negative 2, so we get negative 12y minus 18. Bring down the minus y equals 8. We combine like terms. I've got that negative 12y and the negative y. Remember, that's like a negative 1y, so I've got negative 13y. Minus 18 equals 8. We finish this off by adding 18 to the other side. Eight plus 18, it's 26. Divide by negative 13, and we find that y equals negative 2. Okay, and now we need to find the x value, and so I plug this right up into that equation for x, right? X equals 6 times y plus 9. We now know that y equals negative 2, so 6 times negative 2 plus 9, that's negative 12 plus 9, and that gives us negative 3. So x equals negative 3. As an ordered pair, we've got negative 3 for x and negative 2 for y. And that, again, if we had graphed these two equations, that would be where they would cross on the graph as well. Next, I'm going to give you an example to try on your own. So here's our third example. Go ahead and write this down. Find the easiest variable to get by itself, right? Think of which one would be the easiest in the fewest steps to get by itself. And it doesn't matter if it's x or y. And use the substitution process that I've shown to solve for both your x and y variables. All right, so here's the solution to this system. Negative 7 for x and 0 for y. I've kind of broken this into 3 steps. So notice in my first step, I got this y variable in the second equation isolated. I chose that as the easiest variable to solve for because there was only one step. All I had to do was add 3x to both sides. I didn't have any divider, right? There was already a positive 1 in front of y, so that made it the easiest to solve for. It didn't end up with any fractions or anything. And then I plugged that up into the top equation for the letter y, because that was its substitute. And so there it is right there, 3x plus 21, solved for x. And then after you get your answer, you plug that x value of negative 7 back into either of the original 2 equations, or it could be this equation where we got y by itself, and we plug in there for x. I got 0. So negative 7, 0. Now there are 2 special case scenarios when we're solving, okay? One of the special case scenarios will be demonstrated here. So let's look at 12x plus 2y equals negative 18, and 6x plus y equals negative 9. So here I would definitely choose this positive 1y to get by itself. So after subtracting that 6x from both sides, I get y equals negative 6x minus 9. And I'm going to substitute that in for y in the top equation. Okay, so I'll rewrite that out. I'll go to red. 12x plus 2 times, and then this is where I plug in the negative 6x minus 9, and then equals that negative 18. Okay, so the only thing that I've changed in that equation is making that substitution for y. And now I solve. So I've got 12x, and then I'm distributing, right? So 2 times negative 6x is negative 12x, and then I've got a negative 18. Okay. Now notice in this step, as I go to combine my like terms, they add to 0, right? They totally cancel out, and all that I'm left with is negative 18 equals negative 18, and no variable. Okay? So if in this final answer here we have no variable, as we're trying to solve, but we do have equality, right? Negative 18 is equal to negative 18, okay? So we do have equality. Then we say that we have infinite solutions, okay? This is the scenario where if we were to graph these two equations, they actually would be exactly the same line. They would lay right on top of each other, and we would say there are an infinite number of solutions. Okay, so infinite solutions. There's nothing more that you need to do to solve this equation. Once you get your variables canceling out right here to 0, you look to see if you have equality, and if you do, infinite solutions. Okay, so that's special case number 1. Let's look at the second one. Okay, I'd like you to go ahead and write down this system of equations. This is going to show special case number 2. Our easiest variable to solve for is going to be this positive 1x here. So I'd like you to isolate that x, make your substitution into the second equation, and try to solve and see what happens. So I'll pause the video, and then we'll kind of compare our answers here in a moment. Okay, so you might notice that as you try to solve for your first variable, okay, here I'm trying to solve for y, but my y's canceled out. There's no y's, no variable left over, and then I look at what is left, and I do not have an equality, right? I know that 8 is not equal to negative 8. So if these are not equal, and we have no variable, then this is our second scenario, and this is the no solution. Okay, so we either have infinite solutions if these two are equal, and we have no solution if the remaining two numbers set equal are actually not equal to each other. And those are our two special case scenarios when using substitution method to try to solve our system.